I welcome you to this first lecture. The lecture has 3 parts. In the first part, we talk about the definition of climate. What is actually climate? You know, your neighbor comes, knocks on your door and asks you, what do you mean by climate? What is this? Okay. I'll also introduce you to key climate indicators. Okay, what is a climate indicator? And what are timescales? Okay, we talk about timescales. Something lasts 2 to 3 years or happens every 2 to 3 years. What do we mean by that? Okay, in part B, I introduce you to different vegetation zones on Earth. Okay, vegetation and climate are closely related to each other. Okay, and in the last part, in part C, we talk about global climate change anxiety, because it's a very tough topic to talk about. Global climate change has severe consequences, devastating consequences, and it's tough to talk about it. And I want to give you an idea, some ideas on how to cope with it. Okay, part A. What is climate? So what do you think is climate? Okay, so the first what we think about first is what actually controls life on land. If you think about it, it becomes clear that life on land is limited by temperature and water availability. Okay? Both are controlled by atmospheric processes. There's no life if it's too hot, there's no life if it's too cold, and there's no life if there's no water. Okay? So what climate now refers to are the average atmospheric conditions on land. Okay, we're talking about air temperature and precipitation. Okay, the rainfall. There are the key features of the climate, also called climate indicators. Okay, they're called climate indicators because that's how you can actually measure climate. Okay, through measurements of air temperature and measurements of rainfall. Okay, the vegetation of a region strongly depends and feeds back on the climate. There's a strong link between climate and the vegetation that you get, the type of vegetation that you get. Okay, in the end, you will actually also learn that in the end it's all about heat fluxes and changes in heat fluxes. So this is what controls the entire life cycles, dynamics on Earth are heat fluxes. That's the only reason why I included that little soup. I might be a little bit hungry too, but I included that little picture of a tomato soup. So how hot is this tomato soup? And if you heat it up from below, indeed, it will get warmer. Okay. Take it away. Definition of climate. Okay. So, how do we define climate? So, definition number 1, you can define the climate of the region by the average seasonal cycle of air temperature and precipitation. Okay? Average seasonal cycle. Okay, with seasonal cycle, we talk about summer. What's the average temperature in summer? Okay, winter, what's the average temperature in winter? Okay, what's the average rainfall in spring? What's the average rainfall in autumn? And this information, you can derive it from weather data spanning more than 50 years. The second definition is, that's an alternative now. You can define the climate by the type of vegetation that dominates a region. Okay, what type of general vegetation do you have in the area where you live? And we're not talking about microclimate. We're really talking about regions where on spatial scales of thousands or 500 to 1,000 kilometers. Okay, information on vegetation changes, on the other hand, for example, derived from sediment cores, can be used to reconstruct past climatic conditions. Okay, that's already a little hint on how can we reconstruct past climatic conditions. Weather is something else. Weather is completely different. Weather comes as so-called synoptic weather patterns, causing air temperature and rainfall variations on a timescale of 2 to 5 days. Here is already the reference to timescale, the word timescale. What does it mean? Timescale, if a storm passes through, it normally lasts or takes between 2 and 5 days. After that time scale, it's much calmer conditions. And that's what we call a time scale. However, weather patterns modify the climate of some regions, not of all regions on Earth. There are regions where that experience no significant weather patterns. Okay. All right, we're talking about time scales. Let's keep talking about time scales. Key time scales. Okay. Key time scales. And we're just not talking about precipitation, we're talking about air temperature variations. Just to keep it simple. Okay? Just think, you measure temperature. Okay, you buy a little air temperature sensor that you can link to your mobile phone. You measure temperature. And then there are specific time scales that characterizes your data. And the smallest time scale that you find of coherent repeats in your measurements is the day-night sunlight cycle. That comes from the Earth rotation, because the Earth rotates, we get night time and daytime, and we get a temperature cycle, colder during the night, warmer during the day. And the time scale is 24 hours. And we can say that because it repeats. Repeats every day. Every day, from one day to the next, we get a repeat. Okay? The next time scale is that associated with weather patterns, with storms. Okay? 2 to 5 days. I said it before, that's a typical time scale. Okay? Doesn't tell you how often the event occurs in an area. I'm just talking about if there's a storm, it will be over on time scales between 2 to 5 days. So, the next longer time scale is the seasonal time scale. Time scale of 12 months is the seasonal cycle that comes from the tilt of the Earth axis. Okay, where we have summer, we have winter, okay, we have spring and autumn, okay. And I'll show you a little example of that. Here's a little example. Let's get my pointer working. Here is my pointer. This is the monthly temperature for Poland. Okay, so we're in wintertime, northern hemisphere. It's January, and you can read off the temperature. Temperatures are given here on the y-axis, and they are given in Celsius, degrees Celsius, or in Fahrenheit. Okay, and you can see that high temperatures are illustrated in red, cold situations are given in blue, and sort of in between is given in green. And that's typical colors that are used to illustrate warm or cold conditions. And you can see that there's a clear, distinct seasonal cycle. These little white dots here show you the average daily temperatures, but you can also see the maximum day temperature is the top panel here, and the average nighttime temperature is at the bottom. So you see a range of temperatures, but also from 1 month to the next. There's a distinct seasonal cycle, and you can expect that it repeats from 1 year to the next, from 1 year to the next. So you get a typical cycle and temperatures. Okay, so this is an image that shows you actually the day and night cycle and the seasonal cycle. Again, that's key timescales. However, there are also variations from 1 year to the next. It depends on the region where you are, okay? And we talk about that later on. But there are regions when some years you have relatively dry conditions, and then in other years you have wet conditions. You know, I'm talking about El Niño, La Niña events. And this is to do with interannual climate variability. And the time scale is 3 to 8 years. Okay? And this is not how long an event lasts. This is about the time scale of what's the typical time span between events. So you have a big El Niño. When do you get the next one? Okay, and we talk about every 3 to 8 years. Okay, so the next longer time scale is exceeding 20 years. Unfortunately, we have anthropogenic climate change. This is caused by humans. It's caused by the emission of CO2 and other greenhouse gases. Okay, that currently leads to a dramatic warming effect and other features. Okay, and the time scale of that is unfortunately very short. Exceeds 20 years here, and it will it's a dramatically short time scale. Much shorter than natural climate variations like ice ages, like hothouse, icehouse climates. We will be talking about that later on. The natural time scale of these events exceeds 100,000 years. Okay, to 1 million years. All right, so that's the end of the first part.